Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video, we will cover the concept of Wheatstone bridge. Here, this Wheatstone is the name of the scientist, and this bridge is actually the arrangement of the resistors in such a way that it make a balanced circuit. And here is the galvanometer, and this arrangement is actually referred as bridge. So inside this circuit we have the four resistor. First one is labeled as P here, and this is the Q resistor, this is the X resistor, and this is R resistor. This resistor is actually the called the variable resistor, and this symbol for the variable resistor. The aim of this bridge is to find the resistance of unknown resistor, and which is here labeled by X. So let's we have the four resistor. The one is the P, and which is the known, its value is known. Here is the Q, its value is also known, and the value of R is known, but we will vary that according to our purpose uh, in order to achieve the balance bridge, mean in order to zero this current which passing through this galvanometer. And this X is actually the resistance of unknown resistor. Here we will connect the unknown resistor in this part of the bridge. So here in this bridge it consists of the battery. Here inside the battery there is the electromotive force, and due to that electromotive force, potential difference is developed along the terminal of the battery. Here let's say this is positive terminal of the battery, and this is negative terminal of the battery. And due to the potential difference, the electric field is developed inside the conductor throughout this bridge, and due to that electric field, the force F will exert on the electrons, and due to which current is flowing in this way. So here we have the current I flowing in this conductor, and when it reach here to this junction, at this junction the Kirchhoff's current law is applied, and at this junction. Here, that current I will convert it into I1 and I2. So here it will be distributed to I1 and I2. In this side, the I1 current will flow, and here again the junction, and at this junction the Kirchhoff current law say that this entering current will be equal to the current leaving this junction. So here the current I2 is equal to, so here the I2 will be converted into I3 and I4, and it is clear that I4, the current I4 is actually this I1 minus this I3. And in the same way, here this current divided into I1 and I2, and this I2 will go ahead, and here from this part the current is I2, and from this part the current is I3, and here it will be combined at this junction according to Kirchhoff's current law. The current I5 will be move in this will pass through this resistor. So here this I5 is equal to this I2 and this I3. So this is actually come from the Kirchhoff's current law, and here will have I5 come from this resistor, and I4 is come from this resistor, and at this junction, according to Kirchhoff's current law, uh, these two currents will be add up. So here is that these two currents when add up, it will give the magnitude of the same current. as it enter to this arrangement of this resistor. So here again the current I will flow in this direction toward this battery. So this was the construction of the Wheatstone bridge, and now we will apply the mathematical operations and we will find the resistance of unknown resistor here, which is labeled by X. After arrangement of the current in the circuit, now our aim is to tune the resistance of this resistor, which is a variable resistor. Mean we will increase or decrease the resistance of this variable resistor, and our aim is to zero the current which is passed from this galvanometer, and the increase and decrease of the current I3 is depend on the current I1, and that current, the increase and decrease in magnitude of the current I1 is depend on the current I2 here. So from this variable resistor, we will tune this current, and we will try to make this current I3 as 0. So when the current I3 is 0, then we will call this bridge as a balance bridge. So we will call this as a balanced bridge. And in balance bridge, the current I3 will be 0. So the current I3 will be 0, mean that the current will not pass through this galvanometer, and here the galvanometer will show us the 0 deflection. This was about the current I3. So after this case, focus here. If the current I3 is 0, then what about this I4? Then the I4 here will be, this equation will be I4 is equal to I1, and this I3 for the balance bridge is 0. So therefore I4 is equal to I1, and let's say we have this is equation 1. And similarly we take this current here. This current is given by this. So I5 is equal to actually I2 and minus plus I2 plus 0, which implies that I5 is equal to I2, and this is equation 2. Now we will find the potential difference across each resistor. So the potential difference here from A to B is given by VAB, which is equal to VA minus VB. And here the V is actually given by the Ohm law, which is equal to V is equal to IR. So in this case, this V is actually equal to VA minus VB, and which is equal to this potential difference is equal to the current, and here the current I1 is passing through this and R, and here the resistance is P. So here is the resistor P. So this is equation 3 we have. And the potential difference here from B to C is given by VBC, which is equal to VB minus VC, and which is equal to here the current is I4, and the resistor is Q. So we have this equation 4, and similarly find the potential difference across this side. So here we have the potential VA and VAD, which is equal to VA minus VD, and this potential difference according to the Ohm law, which is equal to IR, and the I in this case is I2, and the R is this case is that resistance R. So we have it is and this is actually equation 5. And for in similar same operation do for this last part of this bridge. So here we DC D and C, which is equal to VD minus VC, and which is equal to the current here is I5 into resistor which is a resistor which is actually X, and this is equation 6. Now, as we know that here the current I3 is 0. So, when the current I3 is 0, so the potential difference across the B and D is given by VB, and VBD is equal to VB minus VD is equal to IR. So here let's say we have the current I3 in this case, and our resistance is actually G, and in this case this I for the balanced bridge is 0, therefore its value is 0, because here this I is 0. And according to this we know that here VB is equal to VB minus VD is equal to 0, and which implies that VB is equal to VD. So this is the equation 7. So up to here we find the potential difference at each part in each part of this balanced bridge. So after this we will rearrange this. So here we have VB is equal to VD, and we will put instead of this VB as the value VD. Here this VB is equal to VD, so equation 3 will become, this is equation 3, which will implies that here VA minus VB, and here this VB is equal to VD, so VB minus VD is equal to here I1 and P. Let's say this is equation 8, and similarly this equation 3 will be modified. This is equation 4. Equation 4 will implies that VB, and instead of this VB we will put VD, so here this becomes VD minus VC is equal to I4 and Q. This is equation 9. So in this case, in this equation we don't have the value of VB, and here is no VB, so this is equation 9. Now compare equation 8 and equation 5. So compare equation 8 and equation 8 and equation 5. Equation 5. So here in equation 5, the left side of this equation 5 is VA minus VD, and the left side of this equation A is also VA minus VD. So the left side of these two equations are same, therefore we can say that the right side of these equation will also be the same. So here the right side of this equation is where this equation is the right side of equation 8 is I1 P, which is equal to the right side of equation 5, which is equal to I2 and R. Let's say this is equation 10. Now again compare equation 9 and equation 6. compare equation 9 and equation 6. The left side of equation 9 and equation 6 is same, because here Vd minus Vc and here is also Vd minus Vc. So we will also the left side of these equation are same, so therefore the right side of these equation will also be the same. So here I can write is the right side of equation 9 is I4 q, which is equal to the right side of equation 6, which is equal to I5 and x, and this is equation 10. And now according to equation 1 and equation 2, this let's say we have equation 1 and I'm going to label that. So here according to equation 1, the I1 is equal to I4. So instead of this I1, now I will write I4. So due to which the equation 10 will be modified. So here instead of this I1, I will write I4, because here I4 is equal to I1. So this I1 become I4, and this is the P, which is equal to I2, and this is the R, and let's say this is equation 11. Similarly, we have this equation here. I4 is equal to I1 here. So I4 is so here I5 is equal to what we can say, I5 is equal to I2. So according to equation 2, this I5 will be is equal to I2, and hence write their value here. So this equation, this is actually we have equation 11, because this is 10, 11 and this is 12. So equation 11 will be modified as I4, which is I4 into Q is equal to, instead of this I5 I will write I2. So this will be equal to I2 into X, and this is equation 13. Now divide equation 1 and equation 13. So here we will divide that. So divide equation this. So we have equation so here we have equation 12. Divide equation 12 on equation 13, and which implies that here equation let's say we have equation 12 is actually I4 P is equal to I2, and this is the R, and divided by, so here this is I2, which is divided by, this is equation 12 and this is equation 13. So that will divide by equation 13, which is given by I4 Q, okay, and this is the I2, and this is the X. So here this I4 I4 and I4 will be cancelled. So here this I4 and I4 cancel, this I2 and I2 cancel, and which implies that the final here is the P, this is the P, and the lower side is the Q, and which is equal to the this is R, and divided by X. So from here we will find, so here by rearrangement it will be equal to the X is equal to R and Q divided by this P, and this is the value of the unknown resistor. So if the value of R is known and the value of Q resistor is also known and the value of P is known, then we will find the value of X from that when the balance is when the bridge is balanced, mean the current I3 through this galvanometer is 0. So the aim of this the aim of this bridge and the aim of this arrangement of the resistor is to find the resistance of unknown resistor. So here we consider this resistor as unknown resistor. So the value of that unknown resistor we find through this formula from the known resistor. So here this is the known resistor, this is the known resistor, and this is the known resistor. And if we multiply the value of the resistor R and Q, this R and Q, and divide that by P, then we will know we will find the value of this unknown resistor, which is actually labeled here as X. So this was the aim of the Wheatstone bridge, and this must the in order to find the value of unknown resistor, it is necessary to zero the current which is passed through this galvanometer, and then we will call this as a balance bridge. So for finding the value of unknown resistor, this bridge and this arrangement in this arrangement the current I3 must be 0. So this was the about finding the value of unknown resistor. So that's it, guys. Thanks for watching.